Hello everyone and welcome. Today we are pulling back the curtain on a silent, insidious force that is actively working to destroy your software from the inside out. It's a threat that plagues every single software project, from a solo developer's passion project to massive enterprise systems. We're talking about code rot, also known as software decay or architectural rot. Now, when you hear the word rot, you might picture old, dusty code from the 1980s running on a mainframe. But that's a dangerous misconception. This isn't about age, it's about neglect. It's about a gradual, relentless degradation of quality that turns once elegant code into a brittle, unmaintainable, and dangerous mess. Imagine a brand new, magnificent skyscraper. Its architecture is brilliant, its materials are state-of-the-art, and it stands as a testament to modern engineering. Now, imagine that small, invisible cracks begin to form in its foundation. A little bit of water seeps in here, a support beam corrodes there. On the outside, the building looks perfect, the lights are on, the elevators run. But beneath the surface, its structural integrity is crumbling. This is exactly what happens with code rot. Your application might still be running, it might be serving users, but its internal architecture is decaying, waiting for the one change, the one new feature that will cause a catastrophic collapse. So, let's be crystal clear about what code rot is and what it isn't. It is fundamentally different from legacy code. Legacy code is simply code that is inherited from a previous team or version. It might be old, it might use outdated technologies, but it can still be stable, well understood, and perfectly functional. Code rot, on the other hand, is an active process of decay. It's the accumulation of technical debt, poor decisions, and shortcuts that erode the code's structure and clarity. It's the difference between a classic, well-maintained vintage car and a car that's been left in a field to rust. How does this rot manifest? It takes on many ugly forms. The most famous is spaghetti code. Have you ever tried to understand a function only to find yourself jumping between a dozen different files, following a twisted, illogical path of calls and dependencies that seems to have no beginning and no end? That's spaghetti code. It lacks a clear control flow, making it nearly impossible to debug or modify without causing unintended side effects. A close cousin is lasagna code, where there are so many layers of abstraction, often with little justification, that making a simple change requires you to modify code in 10 different layers. It's a nightmare of over-engineering that suffocates productivity. Then we have one of the most dangerous forms in the modern era, unmanaged dependency rot. Today's applications are built on the shoulders of giants. We use countless open-source libraries and frameworks. But what happens when those dependencies become outdated? They may contain critical security vulnerabilities. The log4j vulnerability, log4shell, is a terrifying real-world example. A flaw in a single, ubiquitous logging library exposed millions of applications to remote code execution. Teams scrambled for weeks to find and patch every instance of this dependency. In a rotted code base with tangled dependencies, how can you even be sure you found them all? This isn't just a technical problem, it's a massive security risk waiting to be exploited. There's also bit rot, or software atrophy. This is the curious phenomenon where code decays even when you don't touch it. How is this possible? Because the world around it changes. Operating systems are updated, APIs you rely on are deprecated, hardware changes, and security protocols evolve. The code that worked perfectly 5 years ago might fail to compile or run today, or worse, it might run with subtle new bugs because of these environmental shifts. Finally, and perhaps most insidiously, there's knowledge rot. Software is built by people, and people leave. When a key developer walks out the door and the documentation is sparse or non-existent, the why behind the code is lost forever. The new team is left to reverse engineer a complex system, terrified to touch anything for fear of breaking it. This is how a system becomes a black box, a ticking time bomb that everyone is afraid to defuse. The rot sets in because no one has the confidence or knowledge to maintain it properly. It's a slow descent into chaos, driven by tight deadlines, the constant pressure for new features over stability, and a development culture that doesn't prioritize quality. So, we've dissected the nature of code rot and its many forms. But understanding what it is only half the battle. To truly appreciate the danger, we need to look at the devastating real-world consequences. This isn't just about making a developer's job harder, it's about business-ending catastrophes. The impact of letting code decay fester is profound and far-reaching. First, let's talk about money. Code rot is a black hole for your budget. Studies have consistently shown that developers can spend up to 40% of their time wrestling with bad code, technical debt, and architectural decay. Think about that. For every 5 developers you employ, it's like 2 of them are spending their entire day just fighting the system instead of building value. A bug that should take an hour to fix can turn into a multi-day archaeological dig through tangled, undocumented code. Feature development slows to a crawl because every new addition risks breaking 10 other things. This glacial pace means missed deadlines, lost market opportunities, and skyrocketing development costs that can cripple a company. This directly leads to project failure. Imagine a promising startup with a brilliant idea. They rush to build their product, taking shortcuts and accumulating massive technical debt to beat competitors to market. For a while, it works, but soon the rot sets in. The system becomes so brittle that adding the next crucial feature is impossible without a complete rewrite, a rewrite they can't afford in time or money. The competitor who built their system with discipline overtakes them, and the startup collapses under the weight of its own decay in code. This story plays out time and time again. Then there are the security vulnerabilities, the true monsters lurking in the shadows of rotted code. The infamous 2017 Equifax breach, which exposed the personal data of 147 million people, was a direct result of this kind of decay. The attackers exploited a known vulnerability in an open-source framework, Apache Struts. A patch was available, but because of internal process failures and likely a complex, poorly understood system, Equifax failed to apply it in time. Code rot and dependency rot create the perfect hiding places for these vulnerabilities, making systems impossible to audit and secure effectively. Sometimes the consequences are even more immediate and catastrophic. In 2012, the financial firm Knight Capital Group lost $440 million in just 45 minutes. The cause? A software deployment gone horribly wrong. A new system was deployed, but due to a manual error, old, dead code on one of their servers was accidentally reactivated. This legacy code, which was not designed to work with the new system, began firing off millions of erroneous orders, nearly bankrupting the company. This is the ultimate price of architectural rot, a system so poorly understood and maintained that a single mistake can trigger an unrecoverable system-wide failure. But it's not all doom and gloom. We can fight back. Preventing and reversing code rot is not magic. It's a matter of discipline, culture, and the right technical practices. The most powerful weapon in our arsenal is refactoring. This is the disciplined technique of restructuring existing computer code, changing the factoring, without changing its external behavior. It's not a massive, risky rewrite. It's a continuous process of making small, incremental improvements. Follow the Boy Scout rule. Always leave the code cleaner than you found it. This continuous gardening prevents the weeds of rot from taking over. To refactor with confidence, you need a safety net. This is where automated testing and continuous integration (CI) come in. A comprehensive suite of unit, integration, and end-to-end tests ensures that your changes haven't broken anything. A CI pipeline that automatically runs these tests on every single commit gives your team immediate feedback, catching regressions before they ever reach production. This creates a virtuous cycle. Tests enable safe refactoring, and refactoring makes the code easier to test. We can also leverage static analysis tools. Tools like SonarQube, linters, and code analyzers act as an automated code review, scanning your code base for code smells, potential bugs, security vulnerabilities, and overly complex sections. They provide an objective measure of code health and can flag problems early, long before they become systemic rot. Ultimately, however, tools and techniques are not enough. You must foster a culture of maintainability. This means prioritizing quality. It means making code reviews a non-negotiable, constructive part of the development process. It means writing clear, concise documentation. And critically, it requires management buy-in to allocate specific time for paying down technical debt, just like you would for building new features. Building software is a marathon, not a sprint. And a culture that embraces clean code and robust architecture is the only way to ensure your system remains healthy, secure, and valuable for years to come. Architectural decay is not inevitable. It is the result of 1,000 small choices, and we can choose discipline and quality instead. It is our responsibility as builders to create systems that last. What are the worst symptoms of code rot you've ever encountered in a project? Share your war stories in the comments. Subscribe for more and see you in the next one.